Hey there, welcome back to the channel. Today we are going to start Leetcode interview question, that is to sum. So let's see what our question is saying. So in this problem we are given an array of integer nums and the array can be sorted or unsorted, and we are given an integer target and we have to find out the pair from our given array, and we need to find out a pair that add to the target, and we need to return that indices of that pair in any order. So let's see the example number 1. So we are given an input array nums which is having 2, 7, 11 and 15, and the target value is 9, and the output is 0, 1 because the nums of 0 plus nums of 1 is equals to 9. So this index plus this index sums together equals to 9. So we need to return the indexes of 2, 7. Similarly, in the example 2, we are given a nums of 3, 2, 4 and the target is 6. So the output will be 1, 2 indexes. So we are adding indexes 1 and 2 and we are getting the output as 6. So let's see how can we solve this problem. So our target is 9 and our integer array is 21358. So if we add this 1 plus 8, if we add these two numbers, then we can get 1 plus 8 equals to 9. So we will find out a pair 1, 8, and we need to return the indices of this pair. Let's say the indices of this array is 0, 1, 2, 3 and 4. So indexes of 1 is 1 and indexes of 8 is 4. So we have to return this indices. We can return the indices in any order. We can return this as 4, 1 as well. The order does not matter. Let's say another example. We are given a nums. If we are given another array 2, 7, 11, 15 and our target equals to 17, we see 2 plus 15 equals to 17. The indices of 2 is 0 and the indices of 15 is 3. So we have to return 0, 3, or we can say 3, 0. If we are given this array of integers 3, 2, 4 and the target is 6, then we have to return the indices of these two elements, because 2 plus 4 equals to 6. So we have to return the indices 1, 2 or 2, 1. So this is the problem statement. So let's see how can we solve this problem. How can we find out a pair that will add to the target? So let's say nums and the target is 9. First let's talk about the brute force approach. So first let's try to understand how can we find out a pair that add to the target. So the brute force approach is that we are going to generate all possible pair from this array. We can generate all possible pair using two nested for loops. And this is not the most efficient solution. If we generate all possible solution, we'll get 2, 1, 2, 3, 2, 5, 2, 8, then 1, 3, 1, 5 and so on. And by generating all possible pair, we have to check the sum of these pair. If this find out the sum of a pair that add to the target, we will return this indices of that pair. But this solution is not efficient. This solution takes time complexity of O of n square and space complexity of O of 1. So this is not the efficient solution of this problem. The space complexity is efficient we are using constant space, but the time complexity is not efficient. So we can improve this. So we can improve from O of n square to O of n time complexity. For the brute force solution, the space complexity was O of 1 constant, and we can trade off our space complexity for better time complexity. So the linear solution approach, it will take the space complexity of O of n. So we need O of n space complexity for better time complexity. So how can we solve this problem in linear time complexity? In order to solve this in linear time complexity, we have to traverse the array once. So we need to visit every element once. So let's assume we reached this element 5 by visiting the elements from left. We have visited this element, then this, and we reach at element 5. So this is our current element. Now if we find out an element which is 9 minus 5 equals to 4, if we find out an element that exists on the left, if we find out an element of 4 on the left, we have already visited. If we find out an element of 4 on the left that we have already visited, if we find out this element, that means we find out the valid pair, that is 4 comma 5. But this 4 does not exist, that means we have not visited it. So let's move to the forward. Here we have 8. So we have visited 2, 1, 3, 5. So we have to check, do I have an element on the left? 9 minus 8 equals to which is 1. If we find out the element which is already visited on the left, if we can find out the element 1, that means we can find out our valid pair that add to the target. So we see 1 comma 8 exists on the left. But how to check whether 1 exists or not, whether the element 1 exists or not? We can use set data structure. In our set, by traversing, we can store elements like 2, then 1, then 3, then 5. Then we raise the element 8. We reach the element 8. Now we are looking for the element 1. Does this element exist on the left? How to check it efficiently? We can search that element by traversing this subarray. We can check whether we have visited this element or not. So this data structure is efficient in time complexity. So if we find out 1 and 8, so we can return 1 and 8. But here we get a pair. We have to get the indexes. How can we get the indexes of 1 and 8? In order to get the indices of 1 and 8, we need to use set data structure, but we cannot get the indexes of 1 efficiently. We have to search for 1. Then you will get the indexes, right? So instead of storing the element, can we save the indexes as well? So the visited element and the indexes, we can store them. So let's say we are storing 2 comma 0. We are visiting at 1, then we are writing 1 comma 1. If we are visiting 3, then index 2. Similarly 5 at index 3. Then if we encounter 8, we are looking for 1. So we'll check if 1 exists and we'll return the indexes of 1 and indexes of 8, which is 1 comma 4. So I hope you relate the understanding of hash map data structure. We are basically storing key and value pair. We can search for key in constant time. And let's see how it works. Let's create our hash map data structure. So this is our hash map data structure, and where we have key and value. Now let's iterate our array. So this is our first element. Now let's search for 9 minus 2 equals to 7. So do I have an element 7 on the left of 2 that we have already visited in the array? So let's save this element as well as index, because we might have a here instead of 8 we have 7. So eventually we'll raise this element. So we need to search for the element 9 minus 7, which is 2. So does 2 exist on the left? So we have saved this element in the indexes. So we have to save the value and the indexes. So let's move to the next element. This is our next element. We have here 1. Let's search for 9 minus 1 equals to 8. Do I have an element 8 on the left? So no, it does not exist. So let's save this element and the index. Let's move forward. 9 minus 3. So do I have an element 6 on the left? So no, so we can save 3 and the index is 2. Let's move forward. We have here 9 minus 5. So do I have an element 4 on the left of 5? So I see no, so 4 does not exist. So let's save this element and the index. So let's say 9 minus 8. So let's search for element 1. So do I have an element 1 on the left of 8? We can check by searching for key. We can look up the key in constant time in our hash map data structure. So we see 1 exists. So if we find a valid pair. So we find this valid pair. So we know the index of 8 is 4 and the indexes of 1 is 1. So we can return 1, 4 or 4, 1. So this is how we can solve this problem. So this approach will take time complexity of O of n because we are traversing every element, and the space complexity is O of n because we are storing every element in our hash map element. So this is the time complexity and this is the space complexity in efficient approach. Now it's time to implement our algorithm. So first let's create a hash map data structure, and in this hash map we are going to store key value pair, that is integer integer, as key store integer and value is also integer, and this is our map, and map equals to new hash map. And now let me create an array indices, and in this array we're gonna store index of the pair that add to the target, and the size of this array is 2. So now let's iterate this array. So let me write for int I equals to 0 and I is less than nums dot length and I plus plus. Inside here we have to find out the complement. Int complement equals to target minus current element, that is nums of I. So this is our current element and this is our target. So we have to search for this target minus nums I. So do I have target minus nums I on our hash map? And if this integer exists on our hash map, that means we find out a pair that add to our target. So here we gonna check if map dot contains key and complement. If this integer does not exist on our hash map, that means this complement does not exist on our hash map. So we can do that map dot put nums of I and current index, that is I. Else, if this condition is not working, then we have to get the index of the valid pair. So map.get complement, and we can store this map.get into our indices. Indices of 0 equals to map.get complement, and we have to get the indexes of our current element. So indices of 1 equals to I, and we have to break this loop. We have to stop this loop so that we can find out our valid pair, and at the end we can return the indices array. Here we can return indices. So this is our most efficient solution, and this take the time complexity of O of n and space complexity of O of n. Now let's run this code. So yes, our code is accepted, and now let me submit our code. So yes, it is submitted successfully and it passed all the test cases. I hope you have understood this video, and if you have any question related to anything, you can ask me in the comment section. And thank you so much. I'll see you in the next one. Bye.